Hey guys, welcome to another video. So today we will be starting a new lecture on greedy approach, which is a very nice topic. Okay, if you see, it's a well-known topic. Hey guys, welcome to video. So in this approach, we are going to solve a very beautiful question, which is called fractional fractional knapsack. What does question says? We have You have already solved what? Zero on knapsack, then unbounded knapsack. Now we are solving fractional knapsack. In fractional knapsack, there will be a value array, there will be a weight array, there will be a capacity. You have to fill the container with, let's say, vegetables or something which has some weight like 5 kg, 4 kg, 3 kg. You just put it and fill it up. You can, there is an option of taking any item with not wholly, like you can take it like half of portions or any part of this. Can take like for 10 kg, you can take 5 kg or 3 kg, any. Does it depends on you, and you have to get the maximum profit. You are taking plucking out, let's say, some vegetables or something in a container, and then you are going to the market to sell that, and you want to get the maximum profit. So we have something called value array, and we have a weight array. Let's say 60, 10, 100 and 120 is our example. 10, 20 and 30. So item 1, item 2, item 3. Three items. Okay. And the capacity of the knapsack is 50. And you have to get the maximum profit. There is option to take half of it, not fully. You can take it. Okay. Is a what type of question? Optimal problem, because you want to get the maximum profit. You will get some, it is a greedy approach because you have lots of solutions. You want to choose which is feasible, and then you are going to get the maximum out of it. In the greedy approach, we greedily take something. We greedily try to make something. We do greedy things, which we do all the times. Okay. And so in the greedy approach, what we are doing is that we are just, let's say, we will take the maximum profit guy. There may be a possibility that it has a max weight of very high. You can take, like, there is also possibility of taking uh like which has weight less, so that we will fill up small spaces, then for higher spaces, so that we get the maximum profit out of this. There's a possibility. There is also a possibility of getting the maximum um item which is a very high value, taking it, but it may be had very high weight. So there is a lots of thing, but we have to choose greedily what you want to do. Okay. Yeah, so we can make a thing that is weight value by weight array. which will store value by weight. Let's say 60 by 10 is 6, then 50, then 40. This is the value per kg. Okay, 5 and 4 obviously. So these are the value per kg. We will see which has the value per kg more. We'll take that and minus it with 50 minus 10 will be it would be like 40, then minus 20, it would be like 20. Then again, if you want to do 30, it will not be because it is greater. So you have to go in the else condition, which is so remaining divided by it is the remaining weight divided by 30 into value. So 40, 80. Okay. So 80, 80 plus all the items like 60 we have taken, 100 we have taken. So 6, 8, what? 6, 8 is 14, 240. 240 is our maximum profit that we can achieve from this example 1 to 40, which we have already. Let me give you, yeah, which I have already shown. Like getting, if you see nicely, we'll watch it. So we have minused it and we got all these things. Okay. Now, what you're gonna do is that we are gonna calculate the value by weight array. How are we going to do this? It's a pretty good question you have asked. If you see, we have item 1, item 2, item 3. Okay, 3 items. And we want its getting it. Got it though. Yep. Yeah. Okay. I have understood what I'm gonna do. We are going to make items vector, which is pair of value and weight. Yeah, got it. So, see, what are you gonna do? We are gonna make item 1, item 2, and item 3 as a pair of vectors, which will store value and weight. And we are going to sort it. How? We want to sort it not by like any sort. No, it is not that. We want to sort it according to value by weight ratio in the decreasing order because we need maximum to smallest. Getting it? So vector of pair which will store int and int. Okay, and we need, let's say, call it anything, items, let's say items. Okay. Yeah, now we are going to make a loop which will start from 0, I less than, let's say, val dot size plus plus items dot items I dot first was, let's say we are making value first. Okay, value dot uh value of I, and also we are making items I of second, which is will be weight of I. So I have made something. We have made the item which is a pair of first and second, that is value and weight. Okay, we want to sort it. We want to sort it. Items dot begin. Items dot end, and comparator. Make the comparator bool bool comp, let's say pair of int comma int, let's say p1 we have, and pair int comma int p2. We have two pairs p2. Oh, why my hand is not working correctly? I have to do lots of, what do you call this, writing practices. Wait, let me put it in charge. So what it gonna do is that we have, let's say, two pairs. How we are going to sort it? So uh, with second, no, with first, no, we gonna get, let's say, R1 and R2 double. R1 which will be P1 dot first, that is a value divided by how it is gonna sort. Okay, let's say we have 60 and 10, and also we have 100 and 20. We are going to get the first and P2's weight or something. No. P1's first and P1's first and P1's second, I think. Yeah, just divide it value by value, and double R2 equals P1 P2, let's say P2 dot first divide by P2 dot second, that is value by weight. Typecast it to double into double, let's say. Okay, just typecast it to double. Okay, now we have to return true if if let's say P1, that is R1, is greater than R2, decreasing order, otherwise we have to swap it. Got it? Now it is sorted according to the value by weight ratio. I think so. It has done what it has been told. Pretty sure. Yeah. Now, mm, yeah. Now, you can pass it by reference. You can pass it by reference. Doesn't matter because we are not changing it. And here also static because it's not changing. It's just checking. Let us do it again afterwards. Now it has been sorted. Yeah. Now what do we need? We need the mm, maximum profit. So okay, we need the maximum profit. We need a loop which is starting from, okay, no. What do you need? We just minus, we just reduce the value and take the input up to when, up to what? Uh up to when it is our like up to the remainder is let's say like greater than uh less than the weight of I. If it is, then we just move on. Like, so let's see, we have a capacity of 50. We will minus it with the 10. Okay, and gonna add the value, that is 60 to answer. We need an answer also, which is a double, obviously. Answer equals 0. Mm, yeah, just int I 0, I less than value dot size, and obviously capacity. So we have the capacity, which should not be like great is equal to just going out of the loop. Got it? Now we are going to get the remaining weight, int remaining weight. That's the remaining weight. Okay. Uh, just capacity, obviously. Just at first, let's say capacity. If remaining weight, no. If if items, if items dot second, why I do this? That is weight, items of I. Second thing is less or equal to remaining. Yeah, if it is less or equal to remaining, we going to change remain minus equal this value. Does this make sense? Hopefully. And we just have to like answer plus equal forced. Does this make sense? Hopefully. Now, else. Else, if it is greater, let's say if it is greater, then what do you, if it is greater, okay, if it is greater, then items of i's second remaining divided by again into total value. Answer plus equal remaining divided by remaining divided by, oh wait, items of I second. Okay, multiplied by, let's say, value items of i's first. Does this make sense? Yeah. Now let's return answer. Hopefully you have got the more or less something out of it. Okay, compilation error. Um, oh, these things make you think your life choices because this compilation takes whole lot of time. So the problem in the code is that um okay, so the error is that we have to push back elements. Okay, value by weight ratio, pretty simple. Yeah, full item. Break also, we have to break also. We have to break also, na? See, hmm, okay, yeah, yep, yeah, okay. So This is wrong. This is wrong. Can't put it like this. It's empty. It's not doing like this. It should not be. You should like add items. Yeah, items. Items dot push back. You can just push back. You know these things. Why you just value of I and weight of I. Yeah. And now here break. You have to just break it because we have already done and you use typecast it to double. Hopefully it is going to work. No, it hasn't worked. Static member, non-static member. So make it static, bro. Why, bro? Bro, my internet is gone. What? It's too slow. Is my chat is bro? What's up? So, what are we going to do? We are going to do static pull. Yup, yup. If you have already know how to solve these problems, it is very nice to solve. Wow. Now I do, again I fail. Do fail, do fail, do fail. I just solve it and fail it. Bro, what is the error? I don't know. The current weight lesser equals to negative remaining its capacity. We just reduce it. Yeah, and then add the value. Else we just do this thing. But now where is the error? I don't know, man. I think that the last else condition is wrong something somewhere. It might be a possibility. Oh, shit. Okay, just make it in the outside the loop. Okay, and let's see. Okay, now I'm submitting it. Yeah, it is solvable. But why use static and all these things? This is my question, which I will be studying. Let's try to understand why we use static in functions. Static keyword, when applied to a function language in C++, primarily serves to restrict its scope and linkage. Key reason to using static is function declaring a item as static limits its visibility and accessibility to a translation unit, typically the source file in which it is defined. This means the function cannot be called from other source files the same project. This is crucial for fuck. Oh, sorry. What is this? What does it source? Like what? Like static int fun void print. I am a static function. Fun playground. Um. Okay. Like can't be used or something like this or yeah. That file named main.c uses the calc application of static function. Primary application of static function is to limit its scope to the translation unit where they are declared. This helps in achieving two things: data hiding, as we can hide the function from other translation units or files, avoiding function name clashes in multiple file programs. Example of static function: we need multiple program to see the effects of static function. Let us consider C source file. No, bro, brain not working. Curve learned, but still. Assuming that you are using, oops, use static function when they don't depend on any class members. This can still be private, but this way they are optimized as they don't be depend on any instance of the related object. Static, wait, wait, let me get into ChatGPT. Um, we are writing a member function inside a class. Um, why must be static? Sort function needs a plain function pointer or collable like this. Member function inside a class. Okay, you are writing a member function. It is a member function. Bool comp is a member function inside a class. So we need comp must be static. The sort function needs a plain function pointer or callable, but non-static member function has a implicit this pointer. So its signature is effective. Not static. Static removes the need for this, making comp static. Got it. When you are using a member function, we need static. It's just normal function inside the class. It doesn't depend on any object or member variables. Now it's a signature message sort. Just use static. If it make error, just use static. These are some thing we can member functions. We can use static. Yeah, I will learn about it more. Uh, Also, there is some struct items which we can use. Will I solve it with that also? I have used it vector of int, but we can use these also items also. How, if you ask me? So we can do one thing is that to make vector of items, it is not given, so we do not need to do this. Just we have to just items, end items, begin and all that, comparator, a dot value and a dot b dot weight. We know these things like a's value and b's weight, a's value and a's weight, b's value and b's weight, all these things. Item a, item b is a pair, we can say, which has a value and as well as weight. And we just see whether the remaining, if it is weight, if its weight is less than the remaining, then we just minus the weight from the capacity, from the weight of I, okay, and then get the remaining, and just we add that thing. If it is the remaining is the weight greater than the remaining, then we, what do you do, we just fraction it, remaining remain divided by the weight of, like, items of i's weight, or yes weight into items of i's value, then break. Why? Because we have already achieved what we wanted. Okay, because if it is greater we just make it 0, so we break it. We doesn't want to move on because we have already, like, the, what is remainder is obviously is greater than 0. So here one thing we have to change, we can see that remainder capacity is not changing, or remainder is changing, which I've already shown here. You can make capacity also here, but I've made another variable, doesn't matter that much. And in, because it is all double, so make it double all in all the places where you are getting fractions and all. Hopefully you have understood what all these things I have taught in this whole lecture, and you will get deeper understanding of this topic. It's a very nice topic, we can say that. Fractional knapsack, it deeply teaches you the core concept of greedy approach. Like, we just do solve greedily, we take greedily weight by value ratio, because we don't know how are we going to get the weight, the get the optimal solution. Get into optimal solution, we greedily choose something which we which will help us to get into something we want, like optimal, like maximum profit. We don't know whether, if you take the maximum value element but its weight is too much, it would fill half of the 70% of the space. It would not be feasible. Now, it would not be that much profit. Maybe there also can be possibilities of putting small items first and then get the maximum profit out of this. We don't know, so we just divide it value by per kg, you can say per kg weight. So that's how we are getting the per kg weight, value per kg weight. And which has more value per kg weight, we just get that thing and we reduce that thing. if it is like we can take fraction also. Yeah, so from highest to lowest, and then when we have like the if the weight is greater, obviously we take the fraction of it and make it 0 and break. How we make this? We just sort it along according to value by weight ratio. How? By using a comparator like this, which will, let's say, pair 1 and pair 2. You can use items also, doesn't matter. We make R1, which is weight by value of this, weight by value of this, return if this is true, if it holds true, else we just swap it. Okay, we just like swap it and make it sorted in the decreasing order. If you want it increasing order, then you can just make it less than. Hopefully you have understood it. And this is for today. Uh, like, share, and subscribe to my channel. Comment and so that